Educating global leaders is our focus in the Ira A. Fulton College of Engineering and Technology at Brigham Young University. Today I'm here to share with you how the College of Engineering and Technology is changing the way we think. You might be familiar with projects like the Electric Streamliner, which in 2011 set the land speed record at over 155 miles per hour. But the record isn't the most important part of the story. Over the last 7 years, Dr. Perry Carter mentored more than 130 students, changing the way they think about problem finding, collaboration, and innovation. We also had students travel to Peru, where they worked with villagers to understand their needs and to implement life-changing technologies, which provided them with clean drinking water, hot water for bathing, and innovative ways to cook for their families. And in my own Technology and Engineering Education program, several of our graduates have been named National Teachers of the Year for having the most innovative classrooms and instructional techniques.
In addition to recognition and projects like these, undergraduates and graduate students are involved in other opportunities for discovery that have changed the way they think.
In chemical engineering, students are researching drug carrier systems that can deliver anti-cancer drugs directly to a tumor, leaving healthy tissue untouched and reducing side effects. Other students are working on unmanned aerial vehicles that can be used for surveillance on the battlefield and ultimately save lives. Our civil engineering students are collaborating on groundbreaking research in the areas of soil liquefaction and structures to prepare our highways and buildings to resist earthquakes. Going from the seismic to the microscopic, researchers in mechanical engineering have created a tiny DNA nanoinjection device that could possibly be used in the treatment of genetic diseases. Accomplishments like these come from our ability to think as much about the problem as about the solution. We know the quality of our solutions is directly influenced by the depth of our understanding of the problem. This is one way we are being taught to change the way we think.
This is important because in the complexity of today's world, many problems are not well defined. I know that as a BYU student, part of the role I'll play in the world will be to find, shape, and define problems. But I also hope to teach others to do the same. So how do you get someone to think innovatively? The key is to teach them to be good problem finders and definers. Einstein said, if I had 1 hour to save the world, I would spend 59 minutes defining the problem and 1 minute finding solutions. He said in most organizations, people are running around spending 60 minutes finding solutions to problems that don't matter. My parents used to joke and say, Karina can study anything she wants as long as it's engineering. I realized that there's more than one way to study engineering. I loved what I was learning about innovation and design so much that I wanted to teach it. It's a topic that I really love and I feel passionate about, so I hope I can share my passion with others. In 1975, President Spencer W. Kimball said, "We at BYU must carry the torch and light the way. The people who understand and support the aims of BYU are the last line of defense against false ideas." I want to be a teacher so I can share what I have learned at BYU about truth and innovation with others.
Identifying and looking at problems is part of our innovation model in the college. In fact, innovation is one of the 5 strategic initiatives of the College of Engineering and Technology.
Innovation is defined as original and useful ideas implemented successfully. The college knows that if it wants to fulfill its mission of developing men and women that can lead in a global context, it has to understand, teach, and foster innovation. The ability of organizations and individuals to formulate and solve problems, to adapt, and to, yes, change the way they think is what will give them greater opportunity to contribute in the world. Traditionally, in industry and education, the focus has been on implementation. Teachers give a problem and students search to find the one right answer. Implementation is still important, but the time is also ripe to teach and promote divergent thinking. Divergent thinkers shape, explore, and define problems in order to have better ideas to implement. Our challenge in the Ira A. Fulton College is coupling original and useful ideas with impact. Many students come into engineering and technology with valuable ideas. We then provide them with the skills and opportunity they need to turn those sparks of creativity into products, systems, or services that will benefit the world. For the last 2 years, the Ira A. Fulton College has sponsored the Student Innovator of the Year competition, giving students with a good idea the mentoring and funding they need to make that idea into a working prototype.
We got dispatched on a possible apartment fire, smoke alarm was going off. Upon investigation, we found one apartment that was filled with smoke. All we found was that someone had left some beans on the stove cooking and they were smoking a lot. There's over 423 home fires every day in the U.S. that are contributed to unintended cooking. I just started thinking, you know, what if the smoke alarm, when it was going off, was able to cut power to the stove instead of waiting for us to get there? And right then I'm like, wow, you know, is that possible? Is that, you know, if this is correctly implemented, this might prevent a #1 cause of home fires. Then I thought of calling my buddy Mike Sanders, and I knew he's an engineer, mechanical engineer, and going to school at BYU.
He started telling me about the situation and the idea that he had of cutting power when a smoke detector went off. I was like, Pete, that is actually a really good idea.
He gave me some good ideas, and one of the first things he says, you gotta come talk to BYU. They have a lot of good mentors and a lot of good programs in place that can help you with your idea to progress it and to get it to market.
Basically, we had a meeting with the engineering team to kind of outline the functional specifications. There's faculty that we've talked to. I've talked to professors in the electrical engineering department. So you're surrounded by all these experts that have years of experience and almost always some experience in industry. It's just fun to have an idea and bring it into something that is physical and exists and actually does all those things you dreamed it would. I think a lot of innovation is looking at that and seeing what else could it do or what else could it become.
What I hope for this is that it can start to help families, possibly save lives and prevent a lot of damage to homes.
As you can see from Peter and Mike's experience, there's great benefit in not being handed a problem.
Innovation starts with defining a problem and then taking an idea and refining and shaping it. More and more, the problems we all need to solve won't be given to us like homework assignments. Learning to work through the problem-defining process is a very valuable skill.
Another advantage of learning to think innovatively is an increase in critical thinking and collaboration skills. A few years ago, two seemingly unrelated research projects combined to create a new alternative for repairing back injuries and preserving the spine's movement. We work in teams. We keep our eyes on what everyone else is doing. We reframe, we borrow, and we combine to create new solutions.
In mechanical engineering, you look for inspiration wherever you can find it. A great place is actually children's toys. We were given a Jacob's ladder and asked how it works, not only how it works, but how can we modify it in order to fit a certain application. Years later, we were asked to actually look at the spine because it's a compliant mechanism. It bends in order to get motion. And once we found the mechanical properties of the spine, we then started looking for devices that were capable of mimicking it. And in that process, we remembered that several years earlier, we had done this research on the Jacob's ladder. Because we had now understood the basic principle behind that children's toy, we could modify it into an artificial disc.
They had already designed a device, but they needed a way to be able to test it, to validate it. I came into the lab with the task of developing a spine simulator. We were able to validate the design that Peter Halverson had created, and they are actually now running with it and jumping through the necessary hoops to be able to get FDA approval and start implementing it here in the US.
By providing this technology, our hope is that we can really alleviate the pain of others, to be able to take what used to be a very debilitating injury or illness, chronic back pain, and be able to remove that from their lives and allow them to enjoy the years that they have.
I believe innovation comes from experiences, inspiration from our Heavenly Father, and lots of hard work on your part in order to make those experiences and that inspiration just have them realized into a single product.
As you've seen, our ultimate goal is to develop global leaders. Our world is facing many problems that won't be solved until we learn to define them correctly and approach them in a new way. Our college's School of Technology is changing the way we think about innovation through its Innovation Bootcamp, equipping students with the problem-finding, collaboration, and innovation skills we've talked about today.
So I'm going to show you a video right now that talks about where ideas come from and sort of how they generate. And then after that, we'll go to the next stage of this particular part.
keep tension on it. It's all right, it's all right.
Yeah, like a things here. Yeah, we got it.
This class is one of the required classes for our major, and I honestly had no idea what it was. This morning when I came, I didn't know what to bring or what to prepare.
We had to try to brush our teeth as if we were doing it for the first time ever.
It's crazy. Like, I didn't really expect to come here this morning and brush my teeth in class. I didn't realize so many people brush their teeth in such different ways. I thought it was just put some toothpaste on and brush your teeth.
What I learned after that was that I don't know everything about toothbrushing, even though I'm doing it all my life.
Now I want you to take a look at these pictures on your board and start organizing them a little bit. And ask those questions. Why do people do this? What's the real problem behind it?
We're talking about how to break down a problem into its separate elements.
We're presenting ideas right now. The idea that we're working on right now is for a bike helmet.
So we came up with the neat little holder to hold your backpack on the edge of a table or the edge of your chair.
Thinking outside the boxes. It's fun, it gets you energized.
It's a lot more of the process and not going straight to the solution. We would all listen to everybody's ideas and then build off of each one of those ideas.
Before I took this course, I tended to look at innovation just as something for creative people that just, if they had time to sit around, maybe they'd get a stroke of genius from time to time. Now I realize that anyone can be innovative if they're willing to put in the time and use tools like the tools that are taught in this course.
Well, a couple years ago, I was getting ready to graduate in manufacturing engineering technology. Just before I graduated, I took the Innovation Boot Camp. It was really cool for me to see that I could be innovative and I could be creative even though I hadn't thought of myself like that. Going out to work, one of the companies hired me and told me that if I could reduce the cost of one of their product lines by 20%, they'd give me a big bonus. One of the things we talk about in the boot camp is making sure you're solving the right problem. But as I started to learn more about the company, I realized that we weren't solving the right problem. Sat down with the president of the company and we ended up creating a new product line that ended up being one of the most efficient and best-selling lines in the whole company. From that experience and from some others I had, I just realized I needed to know more about how innovation works and ended up coming back to BYU to study what happens in the Innovation Boot Camp and help teach it. I ended up applying to a PhD program and got into the PhD in engineering education at Purdue University so I can go out there and continue to learn more and teach more about what happens here in the Innovation Boot Camp in the School of Technology.